Okay, so a while ago I got this Dyson air purifier heater, and the problem is when you power it on, there's only one button basically. There was an exclamation mark indicating there's a fault. It took me about 1 week to find the problem because without the remote control you cannot enter the diagnostic mode to see what's wrong, so I need to do everything manually. And in the end I found, because I thought, well, it's probably the motherboard because it gives an error directly after boot. So I bought this replacement motor controller that has a Hall sensor input, but it still doesn't work. The motor doesn't work. So I realized that one of the Hall sensor in the motor is broken, and that caused everything not to work. Of course, with a high-speed motor like this, it's not actually needed to use the Hall sensor to drive it. You can use back EMF to sense the position, but of course this is Dyson and they want to do everything complicated. I do not recommend to purchase this device. As you can see, everything is so complicated. I already started to modify it. I removed the main controller. It's the Darlington array for driving the sway, by the way. Here's the sway mechanism. Here's the motor. And imagine that the stepper motor and an end stop. Normally you see this motor on your AC or the camera that can pan and tilt. They usually self-calibrate on boot and do not have an end stop sensor like this. And this one too, it's just, here's the heater track thing. There's even a, I don't know if you can see this. Here's a Hall effects current sensor inside. It's just unbelievable. And here's the head, here's the heater wire. I don't even know what it is because it's not possible to disassemble this without breaking it. So I'm gonna leave it out. But now I'm gonna show you the important part. What's the most interesting? This thing is meant to install here. The way you install it is also very clever. You insert it like this, and you push it in. There's a tab here to hold it, but it's broken. This thing plugs in like this, and this PM2.5 sensor. This is PMS 5003 or 603, sorry. It's a PMS 603. It communicates over serial, as you probably already know. This one. Is SSG31. You probably already know. This is the I2C sensor. And on this board, there's another sensor. There's no marking, or maybe there is some. This is SGP30. It is a ECL2 sensor. This is like using algorithm to calculate the CO2. This is not real, but it provides an estimate. On the board here is a tiny regulator to provide 1.8 volts for the SGP30, because this one is 1.8 volts, which is very rare nowadays. Everything is 3.3 volts basically. It's the 2-level shifter. But see, this is the cable going out. There's 1, 2, 3, 4, 5 pins only. And this is the PM2.5 sensor. There is also 5 pins. So how the hell do they communicate with these 2 sensors? Turns out they decided, let's put they are using STM32. I already removed it because I don't need it. I have to show it in the process removing it. It's a STM32 F424, and basically the STM doesn't have a GPL multiplexer like the EST32 I'm going to put in have, so you can only use the things like I2C and serial on certain pins. And it turns out the I2C and serial is always on the same pins. So what they do is, like, this is the 2 I2C pins. Here's the pull-up resistor. This 2 goes here. This 2. One connects here to the other sensor. The connector of the other sensor. Here's the connector. And basically, here's the pull-up for the other sensor. And you can see it connects to this 100 ohm resistor, and the 100 ohm resistor goes here through to the PM2.5 sensor. They share the 2 pins, the I2C and the serial together. I really don't know about this, if this is a good practice, like in production. Yeah, I did a quick search online and they say it's not recommended to do this, but yeah, they got away with this. In real production, imagine that. And also this thing is so difficult to disassemble. Basically, it's easy to disassemble if you only need to take this part off. But if you want to do anything else, it's extremely difficult. These things go on like this, and you only need to take off this screw from bottom to take this part off. It's very easy. And if you want to take the motor off, in this case it's broken. Here is plastic tabs here. Also on the other side, let me show you here. Yes, let's take a filter off, so you don't need it now. You take off this tab, and here's the ring. This motor is spring loaded. You basically push this in, and you can lift the motor out. Yeah, this is not trivial. It took a lot of time to figure out how to disassemble this, and to put this on the base. You should take the motor off, and there's like 4 screws on the bottom. Yeah, this is also not very trivial, so I need to take the motor off again later. But yeah, that's it. What's inside is super overpriced and cool gadgets, I guess. Yeah, I don't recommend it anyone to buy this, but it's definitely interesting inside. Look, there's even a like light sensor here, so I can dim the display. I'm not gonna use the display anymore. Gonna make it connect to Home Assistant with ESP Home. The new motor driver board inside is just controlled by PWM, and yeah. This video is a bit more technical than my other ones, so if you wanna see more like this, make sure leave a comment down below, and leave a comment down below if this showing the I2C and the serial is okay. I already cut the line because ESP Home doesn't support that, but yeah, it's very interesting. Comment down below, and I'll see you next time. Bye.